Good morning. Today I will discuss one question involving greatest integer function of an inverse trigonometry, and we will use definite integration. So let me give you a brief idea. Suppose we have an integration of say 0 to greatest integer of x squared dx. Now the idea is when we have a greatest integer, it will return an integral value. So because x is lying between dx is 0 to 2, so x is lying between 0 to 2, so x square will lie between 0 to 4. So when x square will lie between 0 to 4, the ideal integers which will come out of the box will be 0, 1, 2 and 3. So if I break it into small intervals, so 0 to 2, at 2 it is 4, it will be 1 at 1. So when I move from 0 to 1, we will have the greatest integer at 0. At exactly x equals to 1, it will be 1. Next, at x equals to what, it will be the next integer 2. So it will be at root 2, x will be 2. So when we move from 1 to root 2, the value of x is 1 to root 2, x square will become 1 to 2 and it will return a value 1. So it will become 1 dx. Now we will move from root 2 to root 3. Obviously, at root 2 it is 2, so at root 3 it will be 3. So root 2 to root 3 it will be 2 dx. And similarly, root 3 to root 4, that is nothing but 2, it will be 3 dx. Now it's basic only. After that you can integrate it. Integration of 1 everybody knows, integration of 2, 3, and we can apply the upper limit minus lower limit formula and we will get the answer. So this is an idea how do we break a greatest integer. One basic example I am taking more in this. Suppose we have 0 to 9, very popular question only, very basic and popular. Greatest integer of root x. Now here x is lying between 0 to 9. So root x will lie between obviously 0 to 3. So when root x is lying between 0 to 3, the output here will be either 0, 1 or 2. Now from 0 to 1, obviously when x is 0, root x will be 0. When x is 1, root x will be 1. So 0 to 1 it will be 0 dx. 1, 2 at x 1 it is 1. Next integer is 2. So it will be 2 at when x is 4. So 1 to 4 it will be 1 to 2 and greatest integer will be 1 dx. At exactly 4, it is root 4, that is 2. So next integer will be 3, which will be at x equals to 9. So 4 to 9, this value is 2 to 3. So we will have 2 dx. So idea is in which particular interval, which integer will be out. That is the idea in solving these kind of problems. After this step, again there is no problem, because after this step you can simply solve. Here it is 0. Here it is x, limit applied from 1 to 4. Here it is 2x, limit applied from 4 to 9. You will solve and you will get the result. So this is basic about greatest integer function and definite integral. Now let me take a good question here. The question is, suppose I have to integrate 0 to 100 greatest integer of 10 inverse x dx. Now because we have got an inverse function here, so I would have to figure out which integer would come out in which interval. So for that I should be very precisely comfortable with the graph of 10 inverse x as well as its range and domain. So if we talk about 10 inverse x, its domain is polar and its range is open bracket minus pi by 2 to plus pi by 2. If we talk about the graph of 10 inverse x, so this will be something like this. Open bracket minus pi by 2 here and plus pi by 2 here. All of you know 10 inverse 0 is 0. 10 inverse infinity will tend to pi by 2. So the graph will move like this. It will become parallel to this line. And 10 inverse of minus infinity is minus pi by 2. This is an increasing function graph. So from here you can figure out if this x, which is polar, so the range is minus pi by 2 to plus pi by 2. Fourth quadrant and first quadrant are the output. So we can say that if the range is, if the domain is 0 to 100, so it is positive value, so range will be only in the first quadrant. That means if x is lying between say 0 to infinity, 10 inverse x will lie between only 0 to pi by 2. This particular portion of the graph is considered. So because I am interested in the integral values, so tan inverse x will lie between 0 to 3.14 by 2, that is roughly 1.5 roughly, right? Now 3.14, 1.5 plus something. So idea is कि when this value is between 0 to 1.5, the only integer which will be out will be either 0 or 1. So we will have output as only 0 and 1. It does not mean whether I move from 0 to infinity also, the output of this greatest integer will be only 0 or 1. Now let me break it into smaller steps. At exactly 0 it is 0. When will this value be 1? Now this is the question. When will tan inverse x become 1? So obviously tan inverse x becomes 1 when x becomes tan 1. Some students do a mistake. They write down at x equals to pi by 4. They consider it as a trigonometric function. It is an inverse trigonometric function. So it will become 1 at x equals to tan 1. So if you move from 0 to tan 1, the value of this will be 0 to 1. So only integer which will be returned outside will be 0. So it will become 0 dx. And when we move from tan 1 to whatever value, whatever means up to infinity, the value will be up to 1.5. So integer which will be returned will be only 1. So if we move from tan 1 to 100, the value will be greater than 1 but less than 3.14 by 2, roughly less than 1.5. So it will be a value return will be 1 dx. So if we integrate it, it will become x, and we applied limit tan 1 to 100. So the answer to this question will be 100 minus tan 1. So this is very simple. So you need to understand what graph of tan inverse x is, what is the domain of tan inverse x, what is the range of tan inverse x. I have previously also I said always that when you get questions of definite integration in JE, you always have to understand basics of functions, because as far as integration is concerned, we have done only this much of integration, and this much of integration is known to everyone. So this is what I wanted to explain in this short video. Thank you.